Would you be ready if the Earth's magnetic field reversed itself? Today, let's talk about magnetic pole reversals. Now, most people probably know that the Earth has a magnetic field. It's kind of like a giant magnet, and that field has a north and a south pole. Now, what makes this field? Why does the Earth have a magnetic field? Well, it has a field because of motion of liquid metals, liquid nickel and iron that move around and flow in the outer core. Now, when this molten metal moves around, it generates an electric field. Now, we're also not the only planet to have a magnetic field. Several other planets in our solar system do, including Jupiter, who actually has the strongest one. And side note, Jupiter also has auroras. So why is it good to have a magnetic field? Well, the magnetic field protects us from what we call solar wind. So that's a stream of charged particles that flow from the sun. And without the magnetic field to help protect us from these charged particles, it could eventually strip away the ozone layer and even some of our atmosphere over enough time. Our magnetic field is actually the strongest around the equator, and it's the weakest around the poles, which is why that's where you tend to see the auroras when they happen. So, one thing to know about the magnetic field and the magnetic poles is that they're not static. They don't stay in the same place. And this is because that motion in the outer core, it changes. It's not a consistent flow or rate all the time. So, the actual location of the north and south poles, at least the magnetic poles, actually changes with time. You can see in this map, it's actually moving in time. And that depends on how these things are flowing and moving in the outer core. That also means that the strength of the magnetic field changes with time, so it can be stronger or weaker. In fact, we do know that the magnetic poles can flip. The North Pole can become the South Pole and vice versa. And so that's happened hundreds of times in the last 250 million years. And that those reversals can last from a few hundred years to 30 million years. And you can see in this image, this is actually a chart showing the magnetic reversals flipping one way and then the other. And it's happened many, many times in geologic history. You know, the last time it happened was about 42,000 years ago. So, how do we know this? We know this because of a field called paleomagnetics. So, the way that works is we can look at minerals or magnetic minerals that form in magma and lava as it cools and turns into rock. And by looking at the dates of that rock was made and the orientations of those magnetic minerals, we can tell what the magnetic field orientation was at that time. So in that way, we can create a map of magnetic pole reversals. So what would happen if the Earth's magnetic field suddenly switched? Well, one thing we know from looking at the last one was that it was also accompanied by a weakening of the field. Now, when this happens, the Earth can become more susceptible to solar storms, and that can result in ozone damage and maybe changes in the weather pattern. And it would definitely be bad for the electrical grid if that were to happen today. But what about just reversing the poles? Well, it would cause problems with satellites and anything that uses GPS. You know, your compasses, instead of pointing north, would point south. It would also affect migratory birds and any other animals that navigate in that way. Should we worry about this? Well, maybe not that much. Plant and animal fossils don't show big changes during the previous reversals when we look back at the fossil record. But the most important thing we should remember is that these reversals don't generally happen on short time spans. Usually, when a reversal happens, it happens over hundreds or thousands of years. It's not a light switch where it just flips all of the sudden. So, if we do have a reversal, we're going to have plenty of time to figure out how to work with it.